So, welcome to my project. I'm gonna show you how this works. I have two repositories, EKS cluster repository to manage my Kubernetes clusters infrastructure as a code. So any changes to the infrastructure through this code applies to my infrastructure hosted on AWS. So we made some changes to the infrastructure. It's planning to see if there are any changes. No changes detected from the local code to the actual infrastructure on the AWS. So it prints us the kubeconfig file that will be used to access the cluster, and it also listed out the nodes that is running on the cluster. And ingress controller has been deployed as the load balancer. So our infrastructure is up and running on the AWS. It's got two nodes. Everything looks fine for here. So on the other hand, we have our project repository. So any changes to the project repository will be pushed, and the Jenkins pipeline will trigger the job, and it deploys the application on the EKS cluster. Let me show you how the automatic trigger works. So there has been a push to the repository, which will be detected by the Jenkins pipeline. It has detected here. So it has pulled the code from the GitHub repository, this one, and the first step, it's just listing the workspace. Then it's doing a Docker compose down to remove all the existing containers and the network and the service. Now it's doing a Docker compose which builds my Flask application, copies a few files there, and it also uh, builds another image called pytest. This image will perform the pytesting tasks to test the Flask application if the code is working all right. Once both the images are built, then the Docker Compose spins up three containers: MySQL service, Flask app, and pytest. Once the services are up, we will do a pytest to check if the application is working as intended, and we can see that all three tests have passed. I have configured the tests to do the test on the paths get, delete, and post. So it will do a test on get tasks, update task, like patching and deleting. So our PyTest performed these three tests. Once the tests have been successful, then the pipeline goes to the next stage, which is tagging the latestly built image according to a Docker tag, according to the GitHub commit tag. So it will help us identify which commit is responsible for the image that is being run currently, and this can help us indeed with a lot of other things like tracking which user made the changes and how the code was changed from the previous version to the current version. So once the images have been tagged, it is then pushed to Docker repo, right? So we are just pushing the MySQL image and the Flask application image, because the PyTest image, it is just for local Jenkins testing. If the Flask app is performing all right through PyTest, then we don't need that image to be actually deployed on the production server. The production server, all it needs is just our Flask app and the MySQL service for the Flask app to store the data on MySQL database. So once the images have been pushed to Docker repository, next we make use of the kubeconfig file that has been stored on the Jenkins servers. Over here, we have the kubeconfig file. This is responsible for the Jenkins server to be able to access the Kubernetes cluster. So it is now first doing a get nodes just to make sure that the cluster is accessible. Then it is deploying the persistent volume. We are creating a persistent volume because in fact we are dealing with databases, and databases needs to be consistent, meaning no data should be lost while we are deploying newer versions of the application, because the image changes, so the volume will change. So we are gonna make the image, any new image being deployed, to use the existent volume. And we are getting a persistent volume claim. So this volume claim takes 1 gigs from the volume that we have specified, and the MySQL deployment will use this volume claim, to store all the MySQL data with this claim. And finally, our Flask will get deployed. Our Flask app has connection to MySQL, so users entering their data will in fact store all their data inside the MySQL, and this MySQL is directly linked to our persistent volume. Our volume is hosted in Amazon AWS. So this is our persistent volume. It uses the Amazon AWS block stores ID, and this is the volume claim. It takes 1 gigs, 1 GB of data out of the 2 GB available, and this volume claim is being used by our MySQL MySQL container, or also known as a pod in Kubernetes terms. So it is mounting its default volume var lib MySQL, where the database data is being stored by default. So this volume mount is mounted to my volume. This volume is coming from a persistent volume claim, and the claim is taking its claim from persistent volume. So that's all done behind the pictures. So if we try to access our, if we, yeah, so this is the load balancer endpoint. We have hosted a service of type load balancer, so we get an endpoint to access our application, which is tasks. So for now, we have just one data on it, and in case if we are gonna maybe post another data, that's done, and we get another one, so we can also try with deleting one of those. Mm, let's delete the one on task 1, or maybe task 2. Yeah, so all the delete operations, post operations seems to be working. And even if there is a new deployment being rolled out, then still the Kubernetes MySQL will still be using the volume, that is Elastic Block Store. So all the MySQL data is now being stored and being consistent. So that's overall of my project. So basically, I have two repositories, one for my EKS cluster. So one for my EKS cluster, and the other one, the EKS cluster, it just has the modules that my EKS cluster is being hosted on, and the another one is the actual application code. So the main part is the Jenkins file. The Jenkins file will do a Docker build based on these two images, and it uses the Docker Compose to spin up 3 containers using the images that have been built. And this image, Dockerfile image, builds the Flask app, which is based on main.py. Dockerfile.pytest will build an image based on test main.py and main.py. So test main.py will test the main.py, which is linked to MySQL service. So all those tests, once it passes, the next step is to create a persistent volume on the EKS cluster, then take a claim, then use this claim with the MySQL deployment, then finally create a Flask deployment, 2 pods or 2 deployments. Deployments in turn creates pods. So once the deployments are done, Flask app and MySQL deployments are up and running, then we create a service of type load balancer, and that is what this ULR shows us all about. So that's it, my project. Thank you.